Alright, so here's my new plan, right? I'm making 27 grams of ammonium chloride. You know, you can get 27 grams into that. That's the minimum water you need. So I jacked it up to 50 milliliters. Make sure I, have it in there. Now I'm guessing when you add 27 grams of the ammonium chloride to the 50 milliliters of water, it probably doesn't, probably condenses. The ions probably take up less room than the actual salt. But I'm just going to say that it's 1-for-1, okay? I don't care if there's slightly more water in there. So if I add them up, that's 77 milliliters of volume of space. Like I said, they're different. These are grams, so I don't really know how much space they do take up when you put them into water. We're just going to say 77. So I'm going to boil that down to 77 milliliters, right? I'm going to filter it, right? Filter it hot. I'm going to do it quick. I don't want it to cool down at all, because I don't want any of the ammonium chloride coming out of solution, right? I'm going to filter out all the stuff that precipitates, which is the calcium sulfate, right? Then the filtrate, the stuff that went through the filter, I'm going to cool that down. That'll be my ammonium chloride crystals, and I'll just wash them, filter and wash them. I want you to look at these solubilities here for 50 milliliters of water. It doesn't matter what it is, even if there's more water in there than I think. It doesn't matter. I did this because it's nice, easy math. This is how many grams of calcium sulfate you can put in there at 100 degrees Celsius. That's when I will start to filter it, right? I will filter everything out, and then I'll have a little bit of calcium sulfate in there. I'll actually have 1.1025 grams in solution, right? Because that's how much will fit into 50 milliliters. And I filter it through, and it's all soluble because it's still 100 degrees C's, right? Now I start cooling it down, cooling it down, cooling it down. I'm going to cool it all the way down to 0 degrees Celsius, right? How much can fit in 50 milliliters at 0? 0.115. 0.1115. That is actually more than what it can fit in there when it's 100 degrees, right? So if there's 0.102 in the 50 milliliters when I filter it, when it's freezing, it can fit even more. It can definitely fit the 0.102 plus another point whatever, 0.09, or whatever it is, 0.009. So nothing should contaminate what precipitates out, right? Because if anything, this calcium sulfate is more, it has more room at 0 degrees to be soluble. Nothing should precip out, right? Only the ammonium chloride should precip out. This is my thinking. Thanks to the retrograde solubility of calcium sulfate, this is possible. Now, if I started out with ammonium carbonate instead of ammonium sulfate, this wouldn't be a problem, because I would end up with a calcium carbonate as my instead of calcium sulfate as my precip, and it's really insoluble. It makes this look very soluble, you know what I mean? So you wouldn't even have to worry about it. I got everything heated up here. I'll filter it out. I got it boiling now, down to about 70 milliliters. This should pretty much immediately start showing some ammonium chloride crystals, and they're not. I'll give it a minute, but if it doesn't show any crystals in a minute or two, I'm going to put it back on the stove and boil it down even more and filter it again. Whatsoever. So that's pretty my point, that the calcium sulfate will not precip out once it cools down. You know what I mean? It'll stay in solution even better the cooler it is. So anyways, I'm going to put this back on the heat. So we're down to 50 milliliters this time. This time I got crystallization. I don't know if you'll be able to see it. See it moving as I juggle the water? It's right on top. So we did a pretty good job. It came out pretty fast there as soon as I filtered it. Get more and more crystals here. And it's still like boiling hot. You can see on bottom just after a minute here, it's starting to get crystal, you can see. The top again is getting thicker and thicker. So I think we did a good job here. I'm going to let that cool down. Now the cooler it gets, the more soluble it is. You know, it's easier to dissolve the calcium sulfates. You know what I mean? It can dissolve even more as it gets colder. So now that should precip out. And you remember last time, it didn't precip out when I let it cool down to all the way to 70. Nothing precipped out. So the same should happen here. The only difference is now there's enough of the water is just evaporated away to where we can get the ammonium chloride. Now, if you really want to doubly make sure that you're not getting any calcium sulfate coming out precipping, you should cover this up with a you know, like cellophane wrap or something like that, or a small recrystallizing dish or something, so that none of the water evaporates, because that's really the only way the calcium sulfate can precip, is if the water level goes down. You know what I mean? As long as the temperature goes down, that's a good thing. It's helping. But if the water evaporates, that's not helping. I don't want you to see here. This is at I think 35 degrees. So it still has 35 more degrees Celsius to go before it's still going to be precipitating stuff out. Look at how little water there is. I mean, this is all salt. See that? I mean, it's wet salt, so, but that's already precip that much out at 35 degrees. Let's see what happens at 0 degrees. Okay, so here it is. It's cold enough. I'm going to put it in this thing. Filter. I'm going to pour that water through with a pump. And I'm going to put some freezing cold water over top of this to clean it up. And I'm going to have the pump on first so that it doesn't dissolve everything. And that's it. Dry it up so see how it goes. So I dried this up. This is the ammonium chloride, and there's only 11 grams there. 27 was the theoretical yield, so that's less than 50%. I do have 40 milliliters of water here that's left. So what I'm going to do is I'm going to heat this up and boil it and take it all the way down to 20 milliliters. Filter it hot and let some more stuff precip out. Why am I boiling it down to 20 milliliters? Because I made 26.8 grams of ammonium chloride, theoretically. I already precipped 45% of it out, 12 grams, remember? That leaves me with 14.8 grams. Now 74.08 grams of ammonium chloride can go into 100 milliliters of water when it's boiling. I have 14.8, so I divided. I got 20%. So if I have 20% of the salt, I need 20% of the water, right? So 20% of 100 milliliters is 20 milliliters. I don't know if you can see that, but I got another 5 grams. It's the stuff in the middle. I put the first batch is on the left and the right. I moved it over because I wanted it to be in the middle to weigh it. So that's 17 grams total, 5 plus 12, and I should have got 27. Keep in mind I could take that water that I just got off of this stuff here, right, and boil it down to 10 milliliters. Remember we boiled it down to 20? I could boil it down to 10, filter it again hot, and let it precip, cool it down to room temperature, and then in the freezer, and get some more grams out of there. But I think I get, you get the gist of what I'm doing here. You get what I'm, you can just keep repeating that 2 or 3 times. We've already done it twice. We could repeat it another 3rd time and get, say, another 5 grams out of there, and then we'd have a really good yield. You know what I mean? This is kind of a crappy yield here, but it's, like I said, you could do it one more time. I forgot to put this in part 1, so here it is. Here's my molar amounts. This is the equation. This is what I used. What I did was I divided all these molar masses by 4. I got 33 grams of ammonium sulfate I used. I got 55 grams of calcium chloride hexahydrate that I used. And my yield should be this divided by 4 would be 26.8 grams of ammonium chloride. I didn't tell you what it is here because I'll do that later in the video. Alright, so here's the yield on my ammonium chloride. It's not very good at all. I got 17 grams. Theoretical yield was 26.8, so I got a 64%. Keep in mind, I probably could have got 5 more grams out of here. Or, I mean, 3 more grams out of here if I did another recrystallization. So that take it up to 20 grams, that'd be 75%. There's my calcium sulfate. Oh. I just wanted to go over a couple things about calcium sulfate. There's 3 main types. Anhydrite, which is the anhydrous kind. Basanite, which is hemihydrate. It's got technically between 0.5 and 0.8 moles for every mole of calcium sulfate. And then gypsum, which is the dihydrate, which is what we made originally. But if you put it in the oven at 170 C, it'll start to become anhydrous. If you only put it in between 100 and 150 C, which is what I did, you'll get basanite. And if you don't do anything, you just recrystallize it without chowing it up or whatever, you'll end up with your dihydrate. What we made is the middle one, the hemihydrate. A lot of people call that plaster of Paris. And I'm going to say that we got the 0.8, because I didn't really put it in the oven that long or that hot. I'm going to say we got 0.8. So I took the molar mass of water, which is 18. I took it times 0.8. And I got 14.4 grams of water for every mole of calcium sulfate. This is the molar mass of calcium sulfate according to Wikipedia. I added them together. It's 150.54 grams for every mole. Now if you remember, we only put in a quarter of what we should have, a quarter mole for everything, right? So I divided by 4. My theoretical yield would be 37.635 grams. I got 34 grams. So let's divide them to see what the percentage is. And I got a 90.3% or 90% yield compared to what I should have got. Because I got 34 grams, I should have got 37.6. So I did lose some. And that's pretty much it on the calcium sulfate.